In C++, both fundamental and object data types are by default passed by value. This means that only a copy of the value or object is passed to the function. Therefore, changing the argument in any way will not affect the original, and passing a large object will be very slow. To instead pass a variable by reference, we just need to add an ampersand before the argument's name in the function's definition. When passing arguments by reference, both fundamental and object data types can be changed or replaced, and the changes will affect the original. As an alternative to passing by reference, we may also pass arguments by address using pointers. This passing technique serves the same purpose as passing by reference, but uses pointer syntax instead. In addition to passing variables by value, reference, or address, we may also return a variable in one of these ways. Most commonly, we want a function to return by value, in which case a copy of the value is returned to the caller. To instead return by reference, we place an ampersand after the function's return type. The function must then return a variable, and may not return an expression or literal as can be done when using return by value. The variable returned should never be a local variable, since the memory to these variables are released when the function ends. Instead, we commonly use return by reference to return an argument that has also been passed to the function by reference. To return by address, we append the dereference operator to the function's return type. This return technique has the same two restrictions as when returning by reference. We must return the address of a variable, and the returned variable must not be local to the function. A thing to keep in mind when using functions is that every time a function is called, a performance overhead occurs. To potentially remove this overhead, we can recommend that the compiler inlines the calls to a specific function by using the inline keyword. This keyword is best suited for small functions that are called inside of loops. It should not be used on larger functions, since inlining these can severely increase the size of the code, which instead decreases performance. Note that the inline keyword is only a recommendation. The compiler may, in its attempt to optimize the code, choose to ignore this recommendation, and it may also inline functions that do not have the inline modifier.